The objective of this lesson is to create a situational equation containing independent and dependent variables and organize a table to display the relationship between them. In previous lessons, we learned a variable is a symbol that represents a number that is unknown. In real-world applications, a variable can be anything that is not fixed or something that changes. There can be two types of variables in equations that show a relationship. An independent variable is considered the input. A dependent variable is considered the output. The dependent variable changes based on what value is placed into the equation as the independent variable. Let's look at the following problem. Economy cars can travel 36 miles for every gallon of gasoline in the tank. What are the dependent and independent variables in this problem? The distance the car can travel depends on how many gallons of gasoline are in the tank. The distance d is the dependent variable, and the gallons of gasoline, g, is the independent variable. Let's write an equation that describes the total distance a car can travel based on the number of gallons in the tank. The equation is 36 times g equals d. We can create a table that shows the distance traveled depending on the number of gallons of gasoline in the tank. We will use the equation to determine the distance traveled by substituting the number of gallons into the equation for g. For example, if 4 gallons are put into the car, 4 times 36 equals 144. If 8 gallons are put into the car, 8 times 36 equals 288. And if 16 gallons are put into the car, 8 times 36 equals 576. The table shows the relationship between the number of gallons and the distance traveled. Let's look at another scenario. The price of a house is often estimated by the home's square footage. A well-kept home in the suburbs of Salt Lake City costs about $99.35 per square foot. What are the dependent and independent variables in this problem? The price of the home depends on the square footage, so the price of the home is the dependent variable, and the square footage is the independent variable. We can write an equation to represent this problem. The equal sign in an equation means the same as or equal to. What is the price of the home equal to? The price of the home P is equal to $99.35 times the square footage S of the home. In this equation, P represents the price and S represents the square footage of the home. We can create a table that shows the estimated price of several homes with different square footage. We will use the equation to determine the price of each home by substituting the different values of square footage for the S in the equation. Each square footage will be multiplied by $99.35 to determine the estimated price of the home. The table shows the relationship between the square footage and the estimated price. Let's look at one last situation. A taxi company charges a $3 pickup fee plus $2 for each mile. What are the dependent and independent variables in this problem? The price of the taxi ride depends on the number of miles traveled. The dependent variable is the price of the taxi ride, and the independent variable is the number of miles traveled. Let's write an equation that describes the total price of a taxi ride, with M representing the number of miles and P representing the price. Since every taxi ride includes a $3 pickup fee, we will start the equation with the constant 3. We will then multiply the number of miles by 2. 3 plus 2 times the number of miles equals the price of the taxi ride. We can now create a table that shows the total cost of the taxi ride depending on the number of miles traveled. We will use the equation to determine the total cost by substituting the number of miles into the equation to find P. For example, a 1-mile ride would be 3 plus the product of 2 and 1, which would equal 5. A 3-mile ride would be 3 plus the product of 2 and 3, which would be $9. And a 10-mile ride would be 3 plus the product of 2 and 10, which would be $23. The table shows the relationship between the number of miles and the total cost of the taxi ride. The objective for this lesson was to create situational equations containing independent and dependent variables and to organize a table to display the relationship between them. We met this objective by examining the situations to determine the variables, writing an equation that represents the relationship between the variables, and then creating a table using the equation.